Hello everybody, my name is Amine Hajji, professor at the Mohammed V University of Rabat. Today I'm going to present you this research work which is entitled The Effect of Light on Anaerobic Digestion Process of Household and Similar Waste under Mesophilic Regime. Our presentation is synthesized according to the following points. First, we will present the general context of the study. After that, materials and the methods. Then we will show the result and the discussion, and we will finish with a conclusion and perspective. Nowadays, waste management is a real socio-economic and environmental issue. In Morocco, the quantities of waste are continuously increasing with a growth rate of around 5% caused by population growth, change in lifestyle, and the development of technology. Currently, the waste sector generates about 10% of greenhouse gas emissions. The anaerobic digestion process allows waste recovery by converting biodegradable organic matter through anaerobic microorganisms into biogas, mainly composed of methane and carbon dioxide. Several research work have studied the influence of many physiochemical parameters on the performance of the anaerobic digestion process. However, few of them have dealt with the influence of light on the anaerobic fermentation process, mainly because of the obvious fact that conventional anaerobic digestion systems operate in total darkness. In the sense that the present work aims to study the influence of light on the production of biogas in the case of municipal solid waste. The municipal solid waste used in this study come from the controlled landfill of Omeza, Rabat region. After recovery of the substrate, physical characterization of the waste was performed, followed by a physical pretreatment to reduce the particle size to 10 millimeters. For the experimental device, we used the BioFlow Silogen 115 type. It's a fermenter with a capacity of 14 liters and useful volume of 10 liters. The experimental device is achieved by a flow meter, biogas analyzer. Fermentation was carried out under a mesophilic regime with a temperature of 14 degrees Celsius with a retention time of 21 days and under stirring intensity of 14 revolutions per minute. The BioFlow digester was placed in the location where it received natural sunlight and the BioFlow digester was placed in a location where it received natural sunlight and artificial light when with an illumination level of 500 lux was used outside the sunlight hours. During the first 5 days, the pH drop was corrected by adding NaOH. So here you have the result of the first study that evaluates the effect of light and total darkness condition on the pH value. As shown in the result of figure 2, an increase in the pH value was observed of the case of illuminated digester due to the reaction of photosynthesis that consumed dissolved CO2 and increasing the pH level, which led to a slight improvement in the pH variation during the first 7 days of anaerobic digestion compared to the result of the unlighted digester. Regarding the second study, it deals with the influence of light and total darkness condition on biogas production. This figure shows the biogas production for the two batch reactor in the light and dark condition. For the one in the light condition on continuous degrees on biogas production was observed from day 7 until the rest of experiment. It reached a minimum value of 0.11 liters per day. This decrease can be explained by the massive presence of photosynthetic bacteria visibly present with a reddish brown color on the internal wall of the bioreactor that could have created a competitive situation with the methanogenic bacteria on CO2, thus leading to a decrease in the activity of both groups of bacteria. For the case of the batch reactor with the dark condition on normal biogas production was observed, characterized by a maximum production from day 13 with 0.36 liter per day that remained constant until the end of the experiment. The third study focused on the effect of light and dark condition on biogas composition. The effect of light on the composition of the biogas is presented in figure 4. The results show that methane content of the biogas for the lighted digester case was 21.5% lower than the unlighted digester case, with a methane content of 51% for the photosynthesis-assisted digester and 65% for the unlighted digester case. Based on the results obtained, it was found that illuminated digester had a low biogas production of about 0.11 liter per day and a low methane content of 51%, which is 14% lower than the biogas production and 21.5% lower than the methane content, respectively, compared to the unlighted digester. In the present study, the anaerobic digestion under continuous dark condition was more efficient than under continuous light condition. Further study are needed to better understand the effect of light on anaerobic digestion using different illumination times with different light intensities. Thank you for your attention.